This is mathheals.com, where you can find more links to YouTube math videos and computer science. And let's take a look at a hypothesis test for population proportion. And we have a definition. When observed results are unlikely under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. This is the p-value approach using TI-83-84. We write down a shortened version of the claim. We come up with a null and alternate hypothesis. H0 always has equals part on it. See if the claim. I'll learn to speak someday. See if claim matches H0 or H1. Step 4: find the p-value using one prop z test. And if p-value is less than alpha, reject H0. If p-value is greater than alpha, accept H0. And then determine the claim based on step 3. And let's take a look at some problems. Let's prove some clams. Okay. According to ABC News in June 2012, 36% of people believe in UFOs in the United States. If a sample of 200 people... Sounds like I got a train right next door to me. I apologize for that. Find that 74 of them believe in UFOs. So X is 74. Test claim the percentage of believe in UFOs is greater now at alpha is equal to 5%. Greater now, so greater than 36%. So greater than 0.36. Well, that's the greater than symbol. What goes along with that? Step 1, write down a shortened version of the claim. Well, we did that when we wrote down the problem. Step 2, come up with a null and alternate hypothesis. H0 always has equals part on it. This is our null and this is our alternate hypothesis. Since we're talking about proportion, percentage, we're going to put P. The greater than goes here, and then this will be less than or equal to. Now the only symbols that you can put on H1 are less than, greater than, or not equal to. The only symbols you can put on H0 are less than or equal to, greater than equal to, or equal to. Now some books, the one we're using in particular, they will always put equals on this H0. I really don't like that form because if you reject this and you accept this, these should be opposites of each other in my view. I know it doesn't matter in terms of actually solving a problem, you get the same answer, but okay. See if claim matches H0 or H1. Well, this is a greater than symbol, and this is a greater than symbol. So it actually matches H1. It says find a p-value. We'll use one prop z test. So one prop z test. Okay, so I'm going to choose stat, right arrow to test, and we want to choose the fifth one. You can down arrow to it and press enter, or you can just press the number 5 that's in front of it. It'll do the down arrow and enter for you. P0 is a number off of our claim, which is 0.36. X we said was 74. N is 200. And the symbol off of H1 is a greater than. So I'm going to right arrow over to the greater than and press enter on it. Down arrow to calculate and press enter. Now the P equals is our p-value. So P is equal to 0.3841. Now using technology like this, you'll get a more exact answer than you would if you did it by hand using tables. So realize that if you're comparing this against somebody else's and they did use the tables, or the books using tables, it'll be different slightly. Okay, if p-value is less than alpha, well, p-value is 0.3841, alpha is 0.05. It's not less than. If p-value is greater than alpha, it says accept h naught. So for a conclusion, we're going to accept h naught. Now h naught and h1 are opposites of each other, so if I accept h naught, that means I reject h1. And since our claim matches h1, whatever we say about h1 is what we say about our claim. So we reject our claim. Now some note on wording here. The accept word, most books will not use that. Let me give you an example. Accept is a pretty strong word. I had a student, she was an art major, and she got 7 or 8% on every test throughout the entire semester in college algebra. She came in to take the final exam. She got 100 on it, 100%. Aced it, which is almost unheard of. Comprehensive final exam in college algebra, very few people ever get 25 out of 25. I think she cheated. I think she brought in the answers. I think somebody from a previous class saved off the answers on their calculator, and she brought them in and just filled them in. I say that because to get 7 or 8% on every test throughout the entire semester, and then to get 100%, the probability is so low. Now, I'm pretty sure she cheated, but I'm not 100% certain she did. So, if I think of these words, I don't accept her innocence. I just do not reject her innocence. So realize accept is a pretty strong word. Usually books will use do not reject. I find students click better if I use accept and reject. Okay, let's look at our second problem. According to Chicago Tribune, in 1990, 74% of teenagers believed in angels. If a sample of 500 teenagers, so N is 500, shows that 410 believe in angels. Test the claim that the percentage is the same at alpha is equal to 10%. Okay, and our claim is, test the claim that the percentage is the same. So same as that 74%. So same as 74%. Well, this symbol, same as, applies an equals. I'm not sure why I wrote a Z. There we go. So let's go through our steps now. Step 1, write down a shortened version of the claim. Yeah, we did. H naught, come up with null and alternate hypothesis. H naught is our null. And equals goes on this. So we got P equals. And this will be P is not equal to. So you see what symbol you get here, and then you decide where to put it. Do you put it on H naught or H1? Well, on this one, step 3, our claim matches H naught. Because this is equals, this is equals. Remember, the only symbols you can put on H naught are less than or equal to, greater than or equal to, or equal to. Only symbol you can put on H1 is less than, greater than, or not equal to. Now, I don't like the book's convention of always putting equals here, because if I wrote a claim a little bit differently, I'd say test a claim that the percentage is at least 36%. At least means greater than or equal to. Well, if I don't allow you to put a greater than or equal to here, then it doesn't make any sense, in my view. I'm sure the people that do that have an equal reason why it makes sense to them. Well, we're going to find a p-value using one prop z test. So let's come over here, press stat, write our tests, and I'll choose number 5, one prop z test. P naught is a number off of our H naught, H1 claim, which is 0.74. Doesn't matter where you get it from. Those same in all three of those. X is 410. N is 500. Symbol on H1 is a not equal to. So I have my flashing cursor on not equal to. Press enter on it. Down arrow to calculate and press enter. Now the P equals is your P value. So we've got P is equal to 4.5 E negative 5. Okay. So that negative 5 means I move my decimal 5 places, decimal point 5 places to the left. So I'm going to have 1, 2, 3, 4, 4, 5. Oh, excuse me. Double check all that. I thought that was a different p-value, but maybe not. 0.74, 410, 500, not equal to. Yep. I guess I was right. Okay, so that's our p-value. It says that p-value is less than alpha. Well, alpha is 10%, and this is 0.000045 or whatever. So it's definitely less than. So for a conclusion, if p-value is less than alpha, reject h0. So we're going to reject h0, which means we accept h1. h0 and h1s are opposites of each other. Now our claim matches h0, so whatever we say about h0 is what we say about our claim. We rejected h0, which means we'll reject our claim. P-value approach is very nice if you have technology that gives you the p-value. If you have to find it by hand, sometimes that can be very cumbersome. Okay, number 3. According to the Chicago Tribune, in 1990, 50% of teenagers believed in ESP. If a sample of 400 teenagers show that 190 believe in ESP. And 50% believed. Claim is percentage is different nowadays. So claim is different from 50%. And alpha is 0.01. I find it interesting. I try to put these same little tidbits in every one of these videos. I do this, the classical approach, p-value approach, and so forth. But I find it interesting that people tend to believe more. It seems like they believe more in things they can't see than the things that are right in front of them. You got people that'll believe in UFOs, but they won't believe in religion, even though you know what God has created is all in front of them. So it's interesting. But they've never seen a UFO. Okay, so these are P's. I guess I ought to go back to my steps instead of write down a shortened version of the claim. We did that. Come up with a null and alternate hypothesis. H-nods are null and different from. That symbol is not equal to, which goes right here. And if that's not equal to, this is equal to. Step 3, see if your claim matches H0 or H1. Well, this is a not equal to symbol. We put that on H1. So this matches H1. And a p-value. We use one prop z test. So press stat, choose cal or test 5.50 x, which is 190, 400. The symbol on H1 is a not equal to. I have my flashing cursor there. I can press enter to select it. But down there to calculate. And press enter. So our p-value is 0.3173. Okay. If p-value is less than alpha, it's not. If p-value is greater than alpha, p-value alpha, it is greater than, isn't it? It says accept H0. So for conclusion, I'm going to accept H0, which means we'll reject H1. H0 and H1s are opposites of each other. Our claim matches H1, so whatever we say about H1 is what we say about our claim. So we'll reject our claim. Okay, let's look at our last example. According to the Chicago Tribune in 1990, 29% of teenagers believe in witchcraft. If a sample of 500 teenagers showed 80 believe in witchcraft. So that's our N and our X. And alpha is 5%. Let me go ahead and write that down. It says test claim the percentage is lower nowadays, so lower than 29%. So lower than 29%. Okay. Step 1, write down a shortened version of the claim. Did that. Step 2, come up with a null and alternate hypothesis. Lower than, if I think what symbol that represents, that's a less than. And that would match this one right here, because that's where we put less than, is on H1. If that's less than, this has to be greater than or equal to. Step 3, this matches H1. Step 4, find our p-value. We're going to use one prop z-test. Again, I'm just going down the steps here. Okay, one prop z-test. Stat test 5. The number off of our claim is 0.29. X is 80. N is 500. The symbol off of H1 is a less than. So press enter on that. And then I'll go to calculate and press enter. And we got, wow, 7.49 e to the negative 11. Now that's scientific notation. That means move our decimal point 11 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 4, 9. Pretty small. When you have a p-value that's very small and very large, that actually tells you something about the claim. Means that it's very significant one way or the other. Actually, let me look at this. 0.29. Notice how it was 16% here. So it's significantly lower, isn't it? 0.29 went to 29%, went to 16%. Okay, so our conclusion. If p-value is less than alpha, well, alpha is 5%. This is really small. Definitely less than. That says we reject H0. So we're going to reject H0, which means we're going to accept H1. Now our claim matches H1, so whatever we say about H1 is what we say about our claim. So we're going to accept our claim. And those are our answers. Now, one other thing I wanted to mention is that if you have a problem that talks about a majority believe, a majority voted, or whatever, what they're saying there, it's an implied P is greater than 50%. A lot of people will miss that one because they think not enough information is given, but that's what a majority means. Let me save this. Maybe. Okay. What in the world? Okay, I'll just choose that one. Okay, hypothesis test for population proportion. It's not classical approach, it's p value. P-value approach, TI-84 problem. I don't want problems. I want page 01.pdf. There we go. Okay, let me save that. And now stop. Oops. Now stop the recorders.